Hey, welcome back to the channel. Hope you're all well. Good to see you again. Thanks for joining. Today I'm going to do something a little different from my usual repairs. VCRs. I used to fix a lot of VCRs back in the 90s. People, that's all they had was a VCR. They didn't have any way to digitally record or store video. It was all on tape. So picked up this one in a garage sale this summer. I thought it would make maybe an interesting video for some of you guys. I don't know. I kind of find these interesting. It's an old Sanyo VCR-6100, and it's a beta machine. It's one of the. It is pretty old. It's got some age to it, some seniority, but it is new enough that it has digital tuning or a frequency synthesizer tuning, which was probably a big selling point back in the day, because the early models had the mechanical tuning, and you know, they had the push buttons for each channel, these ones are a little better. These ones were cable ready. This is 10 key 105 channel cable ready. That was a big thing back in the early 80s too, when cable companies were pumping out all the cable channels on the new bands they opened up. And you can see the kind of the progression here. They had a switch that allowed you to switch between the normal TV frequencies, which was like 2 to 13, and then 14 to 82, I believe it was. And then they had the cable TV switch, which allowed all the intermediate frequency bands. Fine tuning up and down. Let's look at some of the features. Typical fast forward, play, stop, all that. Clock counter. Switch between the internal clock or the tape counter. Reset memory for that. A switch for viewing, monitoring between the VCR tape and the TV. Channel selectors. And then you had two tape speeds, beta 2 and beta 3. You didn't have beta 1. Tracking, audio video inputs on the beginning, on the audio video inputs on the front for allowing to connect to the camera or another source. Thing weighs a ton, and it is packed with electronics and mechanicals. So on the back you have a courtesy outlet, which was unusual for VCRs. On the early ones they had them. Input connectors for your RF and audio video out in case you wanted to run outputs to a video monitor or another VCR to do tape dubbing. Then the channel selector for channel 3 or 4. There's a built-in RF modulator, channel 3, channel 4, and you get to select between the two depending on your location. And yeah, so let's turn it on, see if it actually does anything. Like I said, I got it at a garage sale. They were asking $10. I think I paid $7. And bought it, and it's been sitting on my floor waiting for me to do a video on it. And let's see what happens when we plug it in. I'm going to have a smoke show. I highly doubt it. These things were quite reliable. Well, that's a weird. Can you see that? It's doing a weird flash. It's blinking, and it's quite dim. Let me shut the lights off. Can you see that? I know in the video it looks like it's flashing, but I can see it in real time. It's flashing as well. It doesn't look good at all. Let's do a clock set here. Clock set, hour, minute. Doesn't want to accept any commands. So there's something messed up with the clock. It's powered on. The switch is broken, or it's having troubles here. The switch is having troubles. Okay, that's out, in, and there's no power. Checked. No power. Oh, the timer is on. There we go. Uh-oh. I heard some arcing inside. Timer switch was stuck in. And I heard arcing. It came on for a second. And then it shut off. Oh, that's good. So we've got a problem here. Definite problem. Okay, let's pull the top off, have a look inside. Alright, so I used to love pulling the tops off of VCRs because you kind of find all kinds of unusual stuff that people would stuff in the door. Coins, toys, you name it. Actually, I might have to put the camera down if this is... Yeah, I'm going to put the camera down and then pull the top off. Okay, I got it off. It's kind of stuck on there. So this is the... this is on the right side here. This is all dust and smoke. Or just dust. Looks like there's a... And there it is. Usually these things are just full of electronics. And our tape drive under here. This board here is probably video. This board here is probably tuner. I'm guessing, I don't know. We got some power supply stuff going on here on the side. We got a power transformer, fuses, some regulation on this rusted up heatsink. Got more regulation, and it looks like there's an STK voltage regulator bolted to this aluminum extrusion here. So there's lots of stuff going on. And these things are pretty good for servicing too. You just take out a couple screws and then this board will flip up and give you full access to everything underneath. So let's have a look inside too. Alright, so you remove 3 screws and this board flips up. I'm not sure what this one does. It's probably something to do with the video. But there's a lot of stuff going on here. There's another board on the side that looks like it's all signal level stuff too. There's another board on the back here. Can't really see what that is. Could be audio, video, who knows. Another one here with voltage regulators on it or some kind of transistors. This might be servo control. And then there's probably a big board on the bottom that does all the servo logic. This is a tuner here. And this one here, I don't know, it might be... well, this one has a big gold cap. This is probably backed up. This is your memory backup cap. And then there's a big chip underneath it. So it's probably something to do with the presets of the channels, the clock, who knows with these things. And then we still have more shielding going on here to protect all the mechanicals. So let's pull that shield off and have a look at the condition of the mechanicals. So there it is. Typical beta drive mechanism. You've got your rotary head. It's got 2 heads on it. If I spin it around, you can see the head. It's pretty simple. Hasn't changed much. There's a lot of this that fails on these is belts. So there's a belt here. There's a loading belt. This one probably spins the tape loading reel in. There's a belt down here. This one probably does the cassette eject and loading. And there's another belt I saw. It's down inside here. Probably fast forward, rewind. Pretty much all that goes wrong with these things is belts and tires. Mechanically. Pretty much everything else, they're pretty robust. But this thing's filthy. It needs cleaning. You can see it's just filthy. And a lot of corrosion too. It wasn't stored very nicely. Alright, so let's figure out what's going on with this power switch. Okay, taking the bottom cover off. I see somebody's been in here. I'm pretty sure somebody's had this cover off because this wasn't put together right. This bottom cover should go under these 2 tabs, and it wasn't. It was just laid on top and screwed down. So let's pull this off. Somebody had to poke around in here and have a look. and then they didn't put it back together the way it should have been. Still got one more here. It's so heavy they have to put a foot in the middle. Okay. Okay, here's the bottom inside. It's got corrosion, dirt. But there's not much going on here in the bottom of the mechanical. This is the Capstan Motor. It drives the capstan for the tape, and there's a servo driver. This is the drum motor here. And there's a little anti-static brush on there to keep the static charges down. It's a loading motor for the tape. And then here's your fast forward rewind motor. Don't see much else going on. So let's pull the front cover off, and I want to investigate this switch business. I got the top screws out, and I think the bottom has just snapped into place. Let's try this. Ooh. What was that that fell off? Look how crusty this thing is. It's filthy. Alright, so I got the cover off, and the button that was sticking is a power button. It was actually sticking on the front cover. This power button. Okay, so I turn off the timer. Oh, you can hear that. Let's get my mic a little closer. Arcing or something. So I think we have a problem in the power supply. Let's go after the power supply first. Okay, so here's pretty much the entire power supply on two modules. They come out pretty easy. This one's a transformer and rectifier, a little bit of regulation here. There's a couple of transistors. This one is the STK regulator module inside. So let's have it open up and look at this one. The screws on this are steadfast. It's like the corrosion has got in and locked all the screws on me. Okay. So it's an STK-7216, pretty common regulator for this kind of application. I think it has like a +5, +9, +12 volts outputs. I'm not sure, I can't remember. But if I looked at the data sheet for this, it would tell you. Now, basically, the only thing that goes wrong in these is the connections crack, the solder joints. So let's have a look at this, and maybe we can see. Let's have a look. Everything looks good here so far. A lot of dust and dirt. The connector's got cracks. Yeah, it's cracked. These two on the bottom here are crack solders. I'll solder those up. And capacitors. What do we got here? We got a couple thousands at 16, a 470 at 16. And that is a 33 at 50. Okay, let's check these. It's pretty simple. The power supplies in these are pretty simple. They're all series pass regulators and analog supplies. So this is 0.8, 470 at 16. That's good. 0.8. .08, yeah, sorry. This one here is 30.37, 33 at 50 volts. Pretty good. And then the two 1000s, 0.03, that was good. Yeah, I didn't expect to see any of those bad. Circuit glue is not something I like to see though. I don't know what voltages we're dealing with here, but that can create arcing. This one here is a 2.3, and that is a 22 at 16. That should be good. Okay, let's solder this up. Need my other glasses on. Okay, everything else is checking out. Some heatsink goop. I'm just going to reuse the old stuff. Okay, I can go back in. Let's have a look at this one. The problem with these VCRs with all these multiple connectors is they crack. This one here is definitely cracked. First three, yeah, the first three pins on this connector is gone. That might have been our problem right there. I'm going to resolder all of them. I need to clean my iron one of these days. Basically what you could do is when you get one of these machines is you could take a day disassembling it and resoldering all these connections, and that'll get rid of probably 90% of the problems. It won't get rid of your slipping belts and problems like that, but it gets rid of all your electrical problems. Anything that acts weird in the, you know, and intermittent. This is the problem right here, is these connectors, is they all crack over time because of the heating and cooling. This that one didn't take very good. This VCR has a fairly chunky power transformer, and I'm assuming it's probably about 160 or 100 watts maybe. Probably 60, closer to 60. But 60 watts inside that cabinet is a lot of heat, and things heat up. You watch a movie for an hour and a half and things heat up, and then you shut it off, it cools down, and you got a lot of expansion contraction inside where you get the cracking going on. So I think I got that. Let's see, these two transistors are good. That one's good. And this connector here is okay. I don't see anything going on with it. Oh, I just resoldered that one. This one here, I mean. This one, yeah, I'm going to resolder that one as well. It doesn't look good. And then once you're done, inspect your work, make sure there's no bridges. Yeah, those connections aren't good at all. A lot of corrosion on this thing. It's stored into damp. Alright, now what's going on here? This cap is non-existent. C5041 is open. So let's pull that cap out. And it doesn't look very good. Look at the corrosion on this cap. Let's pull it out, we'll have a better look at it. It's glued down. What does this test out as? This is 100 volt, 22 microfarad 100 volt. This is probably the one that is responsible for the fluorescent display. Okay. So, this capacitor is supposed to be 22 microfarad 100 volts. Comes back at 3.5 nanofarads and an ESR of 466, 67 ohms and climbing. So this one's kaput. Let's get a new cap. Get rid of some of this crap. Okay, so we got a brand new 22 microfarad 100 volts. Next, we have a 10 microfarad at 16. And that is, where is that? Right here. Right here. 10 microfarad at 16. 50. That one's kaput as well. Let's go get a brand new cap for that. Let's test a few other ones while we're here. Save us some time. 100 microfarad at 16. Sorry. Open. Another dead cap. Looks like all these caps. 100 microfarad at 100 volts. Open. What's those other two in the back there? Can't read them. This one's a 470 at 16. $470 at 16. That's okay. And then this one here, I think that's 1,000. Okay, I think that one's good too. So we got a few other bad ones here. 1, 2, 3. So let's replace these. 100 microfarad. What's this big one back here? 50 volts, 220, 2200. Might have to pull this one out to test it. It's showing a short. Let's pull that one out. That circuit glue doesn't want to let go. $2,200 at 550 volts. It's measuring 2283 microfarads, and it's got a 40 milliohms ESR, which shouldn't be bad. Why didn't it come up on the meter? Let's try this again. Okay, there it is, 0.2, 0.3. That one's good. So I'll get the other caps, let's get them in. Put this 2200 back in. Okay, now I got 3 caps here. This one here is the 10 microfarad. So let's pull that one out. What does this one test out as? I'm curious. 10 microfarad at 16 volts. It comes back at 7.8 microfarad, 75 ohm ESR. It's bad. Let's put a new one in. This VCR is getting a lot more care than it deserves, I think, for what it is. It's a relic, we know that, but it's definitely not going to be used for anything serious other than a curiosity or an oddity. Okay, next one was this one here. It's a 100 microfarad at 16. Let's pull this one out. I'm doing this more just for the fun of the repair and, you know, making a video so you guys can see maybe something interesting or maybe learn something from it. I don't know. This one measures out at 40 microfarads, 39, dropping like a rock. And ESR is up around 36 ohms, 37. So this one's garbage too. Put a brand new cap in. When you got garbage caps in the power supply, it just doesn't, the rest of the machine just doesn't want to work. Work properly anyway. Okay. Now, for the last cap, it is 100 microfarad, 100 volts. I don't know if they actually need a 100 volt cap here. All I have in stock is 63 volts. I have like 1,000 of these, so I'm going to see what I'm going to do. I'm going to power up this board. I'm going to plug it in. We're going to see what kind of voltage it has across that capacitor. I don't recommend downgrading capacitors in voltage unless the circuit allows it. So here we go. If it's over 63 volts, we can't use that. Okay, so where is it again? Right here. You got 22 volts on here. Why? 23 volts. So I'm going to swap that capacitor with a 63 volt job, and then we're going to see again if the voltage stays low. So let's pull this one out. This one leaked. Took a dump on the board. What does it measure? Measures at 55, 54 and dropping 250 ohms ESR. So this is garbage as well. Let's put one of these in. Scrape some of this stuff off. Okay, negative. Like I said, I don't know why they put a 100 volt capacitor in there. Let's test it again just to make sure, since we got capacitance back. Right here. $57. Okay, so that 63 volt cap will be safe there. I'm going to leave it. And I'm going to go with that. Now, these other two I'm suspicious of. I'm going to take them out and test them. Even though they tested fine on the ESR meter, I don't think they are good. They probably will be replaced. Guilty by association, right? It's 1,000 at 16. Yeah, we're down to 789 microfarads, 191 milliohms. That's twice what it should be. So this one's bad. That's 1,000. And that one's a 470. I think that one's they're both gonna go out. I'm changing them both. Some corrosion on this jumper here because of the little bit of corrosion on this jumper because of the conductive glue. I'm gonna break the connection here between them. Okay. As you can see, I'm not being too careful with this board. Okay, I need 1,000 at 16 and a 470 at 16. So I'll get those. All right. Normally I don't put used capacitors in, but this time I'm going to. These are good pulls from server. Not that one. That one's garbage. This one here has an ESR probably 5-6 times less than the original, and this one as well. These are both 105 degrees Celsius caps, which were the ones I pulled out are all 85 and they failed. These are 85s, so this is going to be substantially more robust than the original capacitors. Put these in. Maybe a little big, that one doesn't want to fit. I'm going to pull the other one out. But I got the caps in my parts bin. Might as well use them for a thing like this. Something that might never be used seriously again. It's just for get it going. Let's bend this. Okay. This one here, hard to squeak in now because it's Alright, I'm going to give this a little clean, and then I'm going to reassemble this back in the machine, and then we'll give it a test to see how it goes. Oh, one more thing I wanted to check before I leave. I check these fusible resistors. And I can just do that with my ESR meter. So these look like 0.47s. 2.3, 2.3. It's supposed to be 4.7, I believe. This one here looks like a 1 ohm. 10, maybe it's a 10. That's a 1K. That one doesn't have any reading at all, but that might be a 470. Let me check it with my other one. There's corrosion everywhere. Those are wired in parallel. These two are wired in parallel. That's why it doesn't match 4.7 ohms. This one here should be 10. What does this say? Come on. Corrosion is terrible. 10. This one's a 1K. This one here should be 470. Yep. And I think that's it. Don't see any other ones. Okay, I'm going to reassemble this. Alright, I got it assembled, plugged in, and I can see the clock is starting to behave now. No more of that flashing business. So let's turn this on. Still have a bad connection somewhere, and it's arcing. These switches are dirty. It's having troubles powering up. There's an arc somewhere. You can hear it. I think it's this switch. I don't think it's the power switch. I think it's the timer switch. Let's pull that switch out and deal with it. Alright, so I got this board out. It's just a matter of a few screws and a few connectors. And I checked the bottom. There's no cracked solders on this board except for this connector here. There's a couple. I'll touch those up. Now, the problem is definitely in the switch. So I'm just going to spray some cleaner in and hope for the best on this one. Let's see here. Problem is it's hard to get the cleaner in where you need it. The next step would be remove the switch and disassemble it, because it does look like it just snaps together. Let's do the power switch as well. This is what you get when you have switches that don't get used for 20 years. They oxidize inside and then they start getting flaky. Can't really put any deox in there because there's no opening. And I don't like dribbling it down the shaft because then you don't know if it's getting where you want it to be. Let's try this. Try this out. Let's solder this up first. Everywhere you look on this, you're going to find cracked solders on these little connectors. I think that's pretty much it. I'll give it a good visual and then we'll put it back in. Okay, I think I got functionality back here. I got power switch is working. Timer switch is still flaky. I can get it to arc. I just play around with it. But it's a lot better. So I think we can go move ahead with the other parts of this VCR. So we got the power section working again. I'm just going to go over some of these other boards and check solder connections just to clean this up, because I know there's probably other stuff here that's got cracks. So I'll do some of that and then we'll get on to testing it out. Alright, on to phase 2 of this video. Trying to get this dinosaur to work. So I got it all connected. I think I got power to it. I got a video display. I'm not sure if that's getting a signal or not. I got it plugged into the back. We might have problems here. So let's turn this on. We're getting audio through. We're not getting any video. Let's see if it loads a tape. No, the belt is slipping. This belt here is slipping. Okay, it's not loading. So let's take a look at that belt. Just a matter of pulling out this board. There we go. And to change that belt, I need to pull a couple screws out. So let's do that. Actually, first let's move the camera so you can see what I'm doing. So this is the loading motor here. You can see the belt is all deformed on this side. It's all bent. So that belt is shot. We got to remove this screw and this screw. Let's pull this one out. And let's attach that one. I don't know if you can hear music in the background. You probably can. I'm testing a Harman Kardon 330C that I picked up. And it sounds like garbage. It's got missing sound, distortion in channels. So I'm just giving it a test drive, but it's pretty bad. I might have to shut it down and put something else on there. Okay, so one channel's kicking in and out. All right, so we can get at the belt now. What is that? Oops. Four-inch. So I'll grab a 4-inch belt, put it in there. I don't know if I have one that thick though. The switch is still acting up. I got one 4-inch belt here, but it's not quite the same thickness. Let's try it. Might be a little too loose. Might have to get a smaller belt. Okay, try this, put the tape in, move my camera a bit. Let's try this out. Still fighting that. There's not much tension on there. I'm going to pick a smaller belt. I think that original one was quite stretched. Alright, so here's a 3.6 and it's more identical in thickness to the other one, so I'm going to put this one in. It's spring loaded, it wants to jump out. Okay, let's put this on. Wow, that's tight. I probably need a 3.8. Come on, there we go. Okay. Alright, should load now. Eject. Try this a few times. It's pretty crusty, hasn't been used in probably 30 years. Give it a chance to get a little. Okay, so let's see how it loads the tape. Hit play. If I can find the play button. Play. I'm really impressed this thing is working. Unbelievable. We still got problems with the video. Pictures jumping side to side, which means it's got a servo problem. Got a lot of creaky noises coming from everywhere. I think it needs a good cleaning. We got a pretty good picture for beta. I don't know what movie this is, but I'm probably going to get copyright on it, so I'm going to shut it off, and then we'll see what we can do here. Stop. Let's try rewinding it. Let's try rewinding it. We got nothing. Fast forward. Got nothing. Play. Well, it's shut down, and now we got no power. Okay. We got nothing. Power. No fast forward, no play, no eject. It's like it went dead. Not good. Alright, I get the feeling I popped a fusible link here somewhere, because I got no power. I have my timer light comes on if I activate the timer, But I press it, I get no power, I get nothing on the display, and it's completely dead. So let's go back to square one and start checking the power supply again. It was working, we saw it. Alright, so I got the old voltmeter out and I checked a few things and I found a little problem, I think. You can see that. I hope so. This regulator module here, STK 7216, 7210 series, STK 7216S, has two outputs, 9 volts at 1 amp, 12 volts at 3.5 amps. Okay, and this is a chopper regulator. It's probably like a buck converter where they chop it in a because there was a coil on here in capacitors, and they didn't replace any capacitors. I wonder if some of those caps are bad, but it's got equivalent circuits here. And let's see, here's some typical applications here. This is the one I'm interested in. Voltage feeds in on pins 7 and 13, and then your outputs are pin 2 and pin 12, and it gives you values here and everything. But I just want to show you what I get. I turn the thing on. Let me see if I can recreate this for you. Which is the input? I don't know. On this connector, the input is here, and I'm getting 31.5 volts or so. Now if I check all the other pins, 0.66, 0, 0, 0, 0, 0.66, 0.66, 0.68, 0. So I'm not getting anything out of this regulator. I'm wondering if it went bad. Either two things happened. Either this went bad or we have a short somewhere else in this labyrinth of circuitry. And that's quite possible too, because there's so much going on here, and this is all ancient electronics. We could have a bad transistor, a bad capacitor shorted. Could be a lot of different things. So what I'm going to do first is I'm going to change the voltage regulator. I have another one here. And I'm going to put this in, and we're going to see if it comes back to life or not. So, alright, I put a new regulator in, and I also changed out 3 caps because they were showing weak. So let's put this back together and try it out and see what we got for activity on the power front. Shouldn't take me long. Okay. Plug it in. Plug in our VCR. See what we got here. And it's working. We got smoke in there too. Where did I see smoke? I saw smoke out here somewhere. So I'm going to have to investigate this here. Well, we still have power. Whatever was smoking, it kind of blew the fuse, I think. And we got a heated tape. So I'll get this cleaned up. Alright, so we've powered up last time we powered up the VCR, we had smoke. Something went pop again because it went dead. It didn't go completely dead like the first time, but it went dead to the point where it wouldn't function. And I'm pretty sure I saw smoke, but I didn't see where it came from. So what I did is I pull out the Syscon board, or its boards. There are 2 boards tied together, and I believe this board handles all of the system control, because we have logic chips here, and we have a couple motor drivers. We have two of these BA-6209s, and these are a reversible motor driver, and these are suitable for brush motors, so they allow forward, reverse, and braking. So these would be used for, like, for example, for the cassette loading motor. It would load and then unload, and then it would also be used for the tape loading motor, which would spool in the tape and then unspool it. So that's where you'd find these reversible motors. I'm not sure if they would use these for the reel motor, the forward rewind, but now that we have a data sheet on this, I want to check a few things on this board, because I'm not sure we have full functionality. Seems like one of the motor controllers went. So let's have a look at this. Not many capacitors on here, and they're all low value. There's really no heat around here. Not much else to say. There's some transistors. There is a transistor here. It's 2SD325. I could test that right now. Where are we? Base collider emitter, is that what it is? So that tests okay. Let's see, let's reverse these. Okay, we got that, and the diode drop there. That transistor's okay. We also have a TA7257 here. This chip here is also a motor driver chip. It's a Toshiba bipolar linear integrated circuit. It's a full bridge driver for blashed. I don't know what blashed is. DC motor rotation control. Forward rotation, reverse rotation, stop, and braking operations are available. I think this one's probably the one that's doing the action for the reel motor. But we can test some of this stuff too. I'm more concerned about these chips here. So what do we do? Let's see here. Let's pull off this heatsink. It's just in the way, and it makes it difficult to see everything underneath it. You gotta be careful flexing these two, because you don't want to break these wires. They glue the screws in. Oh, that's tight. Okay, let's pull this off. Now, what do we got here? We have 3 transistors. There's a couple of fusible resistors here. It looks like they're 2.2 ohms maybe. Let's measure those. What do we got here? Let's see. Okay, hang on. 2.2 ohms. And we got kilo ohms here. This one's blown. So this might be bad. Another thing we can check is on this we have 2 output devices that control the motor, and these are for here. Let's get a pen. You get your motor here, and one's connected to this leg, one's connected to this leg, so it's reversible. This could be positive and this negative, or they can switch and this be positive and this negative. That's how it works. So these are both outputs, pin 2, pin 10. So let's check pin 2 Where's ground on this thing? Ground is pin 1. Okay. So let's check. This one's suspect. This one's good, let's say. So let's check this here. We got our diode checker. Pin 1. It's pin 2. We got a diode drop there. Pin 10. We got a diode drop there. So let's reverse our leads. Pin 1 to pin 2. Open. Open. Okay. Let's do the same for the other one. Diode drop there. Diode drop there. You got a diode drop there. And open. It's interesting. A little bit of a difference between the two. First, let's change that resistor and see what that does. That fuse blew. And which one is it? Was it this one? This one here blew. Yes, okay. So this one is suspect. So what we need to do is follow the wiring and this circuit here is suspect. So this motor might be the problem. This loading motor here. This one looks like it could be real, RE, and LO is loading. I don't know. But I think this motor is suspect. I think it might be drawing too much current, which is why this fuse blew the second time we tried it, which could be the reason why we blew an STK regulator the first time we tried it. So I'm going to have to trace the wires back to figure out which motor this goes to, and then we're going to really scrutinize that motor. But first let's change this resistor out. And I do have BA6209s here, and if this is blown as well, we'll have to address that as well. We'll change it. Yeah, now that I look at this, I can see a little black spot on it. You can see that on the video. It's on the side beside the capacitor there. There's a little black spot. That's where the smoke came out. So yeah, it's starting to make sense. Here's a better look at it. You can see the resistor looks perfectly normal on this side. If you roll it around, you can see it's... Oops. So I have 2.2 ohm resistors. These are fusible resistors. These are special non-flammable ones. This is what you want to use. You don't want something to start a fire in your VCR. So let's put this in. I'm going to raise it off the board a little. Okay. Now, so what I need to do is find this mating connector and trace the wires back. Which ones were they? Pin 1, pin 2, pin 1, pin 2. I need to trace the wires back to which motor is causing the havoc here. And then we're going to pull that motor out and check it. Maybe it's seized up, maybe it's gummed up with grease, we don't know. Could have a bad capacitor on the back of it or something. So let's do that next. Alright, so the mating connector for this one here, pin 1, pin 2, is this wire. This is the one that fits here. It's a white connector. Pin 1 and pin 2 is white, and white with red stripe. So if I follow those wires, loading motor. And the other two wires, the gray and the brown, go over here, real motor. So that does make sense. That is LO for loading, RE for real. And you get the plus and minus there for as well. So what's going on here? Why do we blow a fuse? Well, this motor is spinning. There's no problem with that motor. This one I can't really turn. But let's put a little voltage to this motor. Maybe there's a mechanical jam. I don't know. So let's try this and see what we can get it to do. I got a power supply here, probably 6 volts on it. Let's try it. I'm going to keep an eye on the current that draws, just to see. It should be able to, that motor driver chip should be able to handle up to 1.5 amps. So let's see. About 600 milliamps. It's moving quite slow. And the belt's slipping. Okay, so let's try reverse. 600 milliamps. Load's normal, and it was only drawing about 150, 200 milliamps as it loaded. Okay, let's unload it. $200 milliamps. Seems like it's working. Why would it blow a fuse? Loaded, unloading. I don't know. I don't know why that blew a fuse. That is really odd. Okay, well, let's put it all back together and try it out again. Alright, one thing I want to do before I put this all back together, I want to test this chip. And what I'm going to do is I'm going to apply voltage to it and see if it's shorted internally, which would cause this fuse to go. And what I'm going to do is apply the positive to the one side of the fusible resistor. The other side of the fusible resistor is on the chip. So if I apply too much current, this resistor is going to pop again. But there's no load. There's no motor plugged in here, so there's no problem with that. So I got my positive connected. I'm going to flip it over. And my negative gets connected to pin 8, I believe. No, pin 1. Pin 1 is down here, so if I follow the trace, it goes around and it goes to this part here. So I got my power supply set for 12 volts. It's on current limit right now, so it's producing 0 volts on the output because the current is turned down to 0. I'm going to connect this up, and I'm going to slowly crank up the current, and I'm going to see how it behaves. Okay. Okay, I'm putting out 1.7 volts and I'm getting 260 milliamps already, which is not right. This thing has a standby current. What does it say here? Typical standby current 12 volts is 5.5 milliamps. Okay, so that's what I should be getting out of this chip, but I'm not. I'm getting over 200 already. Let's try it a little bit more. Yeah, 2.4 volts. I'm already getting 500 milliamps. So that's definitely buggered that chip. I'm going to replace that chip, that driver chip, and then we'll put it back together. Alright, so I got the boards back in, the system control, and even though there's like 20 connectors, it's all pretty self-explanatory and intuitive. They have color-coded connectors, white, black, and red, and then they have different pin numbers, like 3-pin, 4-pin, 5-pin, and so on. And plus, they kind of fall naturally back into place where they belong, so it was pretty easy to just hook it back up. You don't have to draw any diagrams, it's pretty simple. So everything's connected. I did a little bit of cleaning here around the head drum and some of the guides, and just look at the filth I'm pulling up. I'm going to have to pull out the cassette loading mechanism and get in there and do a good cleaning, because there's just a lot of rare areas I can't reach with this in the way. So I'll do that after. But first, let's get a test going here. I got it all back together. Let's plug it in. turn it on. Okay. So, what do we have? We still have this stupid switch arcing. That's the problem. Do we got a switch? Not a sense switch. Okay, let's try loading it. It's trying to unload the cassette because it thinks the cassette is in there, because there is probably a switch that's not. Okay, we're going to have to dig deeper into this. I might have something that's not... Alright, so I had to manually wind the cassette in part way, and then it kind of reset itself. Now it's working. It's loading. It's ejecting. This is in the way it's binding. Okay, that's not secured. So we can do a test now. Let's load the tape. Play. Stop. Okay, so we got loose tape now. Let's try rewind and fast forward. We got nothing on rewind. Fast forward. Fast forward. You got nothing on fast forward rewind. Okay, but play is working. Play. Ooh, it's chewing tape. Okay, so we gotta sort out the fast forward rewind. That's next. That's expected. But it's eating tapes because it's not winding the reels in as it unloads. All right. So let's pull this out and then we can deal with that. Okay, so for removing the cassette tray loading mechanism, I see 3 screws on this side and 2 on this side, and I'm assuming this motor assembly comes out with it. And we have 2 wires here, a yellow and a blue, that go back to the Syscon board that we need to unplug. I got the power unplugged here, I got it off. So let's get rid of this wire to the motor first. If I can reach in there with a pair of needle nose, I can pull that plug out. Can lift it up too, I guess. Okay. Okay, there's our motor wire. Let's pull out some screws. I'm going to try the big screw first. Goes right down into the plastic. 2 smaller screws. This is a machine screw. Another machine screw. This side's loose. Machine screw. Oops, where'd it go? And one more, I think. Another machine screw. Okay, we're loose. We can just take this out. And we have one connector here position switch connector. A 3-wire connector here on the end. And that goes for these 2 loading switches. It tells the Syscon what position the loading is in. Put this aside. Now we got a bad belt here for first off, and we probably have a bad tire too. So let's dig into this. Pull off a E-clip, make sure it doesn't fly across. Let me reposition the camera before we work on this. Now this is fairly typical of when you get no take up or supply reel movement. This mechanism here is pretty prone to failure, so what we're going to do is we're going to service it. There's a number of things going on here. There's a belt, there's a tire, and those are mainly what goes wrong with this, but then it's also lubrication too. So let's pull this E-clip. Put it aside so we don't lose it. And then off comes this first part. Now this is a clutch. There's a felt washer in there, and that provides a little bit of friction. The purpose of the clutch is so that when, oops, there's also a little bearing washer in here we can't lose. A little plastic bearing washer that goes on the shaft. Oh, there's 2 of them. Take these off before we lose them. The purpose of this clutch is it provides a bit of drag so that when the motor starts spinning, what it's doing is it provides, here I'll show you what it does. It flips it to the left or it flips it to the right. And that's all that clutch does, is it gives a little bit of drag so that it drives the mechanism to the left or to the right depending on which way it's spinning. So everything's working good on this. There's really no need to take this apart. You can remove this split washer and take it apart, clean and lubricate the little shaft in there and reassemble, but it doesn't really matter. The main problem with a lot of these old VCRs is the plastic cracks with age. So, alright, so here's our belt. Ugh. This belt is done. I don't know if you can see how badly cracked it is. It's dried up. It's misshapen. It's no longer elastic. It's turning hard. Some corrosion was going on here. I think we got corrosion problems on the pulleys. So we're going to replace that. Then next we have another assembly which provides drive for the bottom part of the reel. So we can take this off. This is just a pulley and a gear and a bearing. Now we got to make sure there is another thrush washer on there, so we got to make sure we don't lose that. I'll have to clean the groove of this bearing, or this pulley. This part here comes out. Let's take this. There's 2 of them on here actually. Oops, I'll find it later. And this tire here is another device that transfers torque to the bottom portion of these reels. These are split reels, they have clutches in them too. So this tire is done. It's kind of glossy and it's hard. So let's see if we can pull it off and find a replacement for that as well. spring loaded for tension. Okay, let's put that aside, put this aside. This pulley is really corroded. Is that aluminum or is that? Okay. Now, these reels, let's check these. These have bearings in them too. That one's not bad. If you release the brakes, kind of noisy. It's like they're dry. So I might just take these apart and clean them as well. That one's noisy too. Let's do that first. Let's re-lubricate these reels before we start everything else. So let's take this split washer out. Hard to do on the camera. Might have to get physical with it. There we go. Okay. All right. So we got another washer here. Okay, there's a bearing down there and a bearing plate that it rides on. So let's clean this up. I'm just going to give it a quick re-lubrication, put it all back together. Sometimes the lube they use gets quite sticky. Okay. This one looks clean. Give it a little bit on the shaft too. That will quiet it up. So typically what I do is this surface that the tire rides on, is I clean it. It's actually like got a little bit of a little tiny micro grooves in it to grip the rubber better. Doesn't want to clean. Sometimes these little grooves, they fill up with trash from the rubber, like dirt and particles of rubber, and the little grooves fill up, and then there's no longer little hills and valleys. It's all smooth, and then your tire slips. But they cast the little micro grooves in this, so that it gives it a better traction. That's not bad, I guess. Look how filthy this is. Okay, so we can put a little bit of lube on the bottom here. A little bit on top. It's a lot quieter. We had a washer. Where is it? If I can find my tweezers. We had a washer. And then we had a split washer. There. Sounds a lot better. Let's do the other one. They're hard to dig out. Bearing washer. And then we have a steel washer that the bearing rides on. So and again we have the bearing on the bottom. Okay. This clutch provides drag so that the real take-up spool has enough torque to keep the tape wound in as it plays. You really shouldn't have to deal with these clutches. They should be, if you had to, you could disassemble this and replace those felt pads, but that's probably really extreme. Most times I've seen these pads just disconnect because the adhesive gives up and then the pad gets loose and then it spins, and then you don't get the clutch effect. You get more of a disconnection. But these ones look pretty good. Okay, let's lube this up. Get out of the way. And I'm just using a synthetic grease. Okay. First up is the steel washer. There's a hair in here. And then we have another washer. Now we can add a little bit to the shaft. Okay. Sounds a little better. Okay. There. Okay, now we can reassemble everything else. First up, we need a new tire. So let's get a new tire on this. I'm not going to disassemble this thing here and lubricate that. I think it's okay. Okay, let's get a tire. This one actually ain't bad. It's just the surface is all dried out. Sometimes what we do is we just flip the tire inside out and put it back on, but that's all nice surface there. Let's get a real tire on this. So what I got here is new old stock. These ones aren't bad. These are pretty good. Pretty close. I'm gonna go with that. Let's put this one on. Voila. Okay. Clean this. Now I believe there was a washer on the bottom here. So let's see. I'm paying attention. It's not paying attention, I guess. Don't need much on here. It doesn't really rotate much. Next up, we got our Pulley and Gear. You clean this with alcohol. Kind of dirty. Okay, I think that'll be good. Let's get some lubricant in this. This one has a bushing inside, so clean this surface too. Okay. Everything's 100% so far. Let's get a new belt on this. Now, what do we need for a belt? I don't even know if I have one this small. 2.5, 2.4. Okay, let's see what I got. Alright, the smallest belt I carry in stock is a 2.3. It's probably going to work. I should have cleaned that first. Doesn't look like it's sitting in there right. I'm going to pull this pulley off and clean the corrosion out of it. You can't see it from where it is, but it looks pretty bad. And I think that's going to make a lot of noise when that starts spinning. So I'm going to take that apart and clean it. Please don't strip on me. I think this is the only size I have. Oh, it's tight. No, I think I'm going to just strip it. I don't have a bigger one. Maybe this one. I don't think so. It's too small. Is this one smaller or bigger? That one's smaller. Nope. Yeah, I don't have an Allen key. So it's going to stay. I'm going to, actually what I could do is spin that motor and I can get a little piece of abrasive in there just to knock off all that scaly rust. That's what I'm going to do. I'm going to spin that motor. And the connector for it is right here. Remember the color code here. We got white with red, white, gray, and brown. So I'm just going to pull out the gray and brown wires. Do this one at a time here. little tangs you just bend down and then it unlocks it from the connector. And if you want to put it back, you just bend the little tang back up again. This one's struggling. Okay, I got the two wires disconnected from the connector, and I probably could have just flipped the machine over and connected to the wires underneath the motor. But too lazy for that. Let's just connect up a power supply here. Thing is, you don't want to backfeed current into the motor controllers because that'll blow them up again. Alright, so I got my power supplies, turned it up. Listen to that motor. That sounds horrible. Wow. Let's lubricate this first. We might have to take this motor apart. Just trying to lift up there's a little washer that's protects the bearing from dirt and dust. So lift it up, and then I'm going to give it a touch of 3-in-1. If I can get it in the right spot. Right there. Got it in. Yeah, let's try it now. Sounds a little better. $12 volts. That's a rough sounding motor. Okay. Give it some speed. I'll clean this. There's dust coming off of it. It's looking a lot better. It doesn't have that green that green corrosion on it anymore. It's gonna have to do. I wonder if I can lubricate the bottom bearing. That's what it needs. Let me flip this thing over and see if I can do that. Okay, there's no access from the bottom of the motor for the bearing. I'd have to disassemble the motor. I'd have to remove it. It looks like it's all crimped and yeah, I don't think it's going to come apart. So let's just put this all back together. Okay, I got my gray wire. Goes in this. And my brown wire goes here. Put that back on the board. Everything's connected. Yes, okay. Now, let's finish this. We got a belt here, 2.3. Did I pull one out already? I don't think so. Did I? Yes, I did. Excuse me while I sneeze. Sorry about that. All right. Good. Let's put this back together. We need this mechanical assembly. And we need a washer. And we need an E-clip. Magnetic tools. Sometimes they're a curse. Okay. Doesn't want to play nice. Here's my screwdriver. Almost got it on. There we go. Okay. So this is all serviced now. We can put the, I want to clean this. I want to put the cassette tray back, loading tray back in, and then we'll do another test. So I'm going to clean this now. I don't think you need to watch. It's just a matter of swabbing the surfaces the tape rides on, cleaning all these posts. There's posts here. I cleaned a couple of them already, but I'll get to the rest of it. All right, so I got the cassette loading tray back in, and then I also, this strut here that I said was bent, that's actually stamped that way from the factory to have that bend in it. And the Capstan motor doesn't, it's got about a 2mm gap in there, so it doesn't really need to be on there. It's held in by magnetism, but I guess it's there to prevent it from falling out. But looks like we're winning. I think we're winning on this one. Okay, so I got, let's try it out one more time here. Let's find a power. That's the, okay, I need the other end to plug it in. Let's try this one more time. We should have our rewind fast forward working now. Still got a bad switch. I cleaned it about 5 times and it just doesn't want to. Yeah. Well, anyways, let's try it out. Rewind. Why won't it go any farther? We're not at the end of the tape, are we? I think we are at the beginning. Okay. Hit play. The awful noises coming out of this thing. And it does do fast forward. Let's stop this and try fast forward. It's working good. So it is working good. I don't know if it's...
Chasing an iguana. What will they do with it? Tie him up, fatten him up, and eat him up.
Okay, so we know it's working, so let's try another tape. Rewind this one. There's a tape counter on this thing. Oh, here we go. Perfect. Let's try another tape. Okay, test again with another tape. This time it's another blank one, so I don't know what's on it. See anything bad, avert your eyes, please. Some kind of movie. This one's in color.
Smell through your mouth.
Excellent. So, I'm going to put this back together now. Alright, so these little switches were still really starting to irritate me. So I decided to pull one out. This is the timer switch. We're going to take it apart. I think it just snaps together. A lot of grease on it. I don't know why it's got grease on it. Oil. I only sprayed contact cleaner. A latch on that side, latch on this side. There we go. Ooh. Pull the cover off. Inside cover has the latch mechanism, little spring, and then on here there's a spring for the plunger. There's 2 sliding contacts there, and then there's 6. Oh, I didn't want to see that. This might be fun. Okay, so what I'm going to do is get some deoxit in here and clean that. Can't really get in there. We're going to deox the crap out of this thing. And just reassemble. Okay, I think I got it. Put this back on. All right. Just going to tack this here for now. Okay, let's pull the other one off and we'll clean that one too. Oops. Pull this other one off, we'll take it apart and clean it. Well, we're not cleaning it, we're deoxing it. Right. I should have just done this from the beginning. Okay. Just don't want it flying apart on me. All right, that should be the end of that. Now let's put it back together, and I got a lot of cleaning to do, and then I'm going to reassemble it, and then we're going to give it a final test. So here we are, we're done. Hopefully we're done. A lot of work went into this one. But then it's an old machine. This is circa 1983, I believe. This machine was put out. It's an early machine because it has a lot of electronics stuffed in it. Later machines, what they did is they scaled back on electronics. They integrated a lot of the systems into certain chipsets and reduced the board count on these machines quite a bit. They reduced them down to a single board towards the end of their life. But these early machines were just packed full of electronics, and this is a good learning experience for a lot of people that want to learn electronics, is get a machine like this and just go through and troubleshoot different systems. It's all pretty basic stuff, but VCRs are complicated. And I remember I had a conversation with a guy at work once, and he was telling me that probably the most electrically complicated machine on the planet was a locomotive. And I argued, no, I think it's a VCR, because there's so many systems and sensors and stuff going on here. There's signal processing, there's all kinds of stuff. There's they use FM recording for the signal in the head, for the video signals, and then there's a separate audio tracks. It's all very complicated. And these VCRs, they actually spawned a lot of the cutting edge technology of the day to get these machines working better and more efficient and having a better picture. They really strive to improve them as the generations went by. This is an early generation machine. It's probably like a third generation, I would guess, but it's still pretty old. And but it works. It works good. Yeah. So like I said, if you ever want to sucker for punishment and you want to learn electronics the hard way, get yourself an old machine like this and start working through all the problems and try and get it going. I didn't have any schematics. I looked online for schematics. I went and did a search. Nothing came back. I didn't put much effort into looking for a schematic, but because, you know, it's all basic stuff. You can just troubleshoot these circuits just by looking at them and following traces on the board, which is a skill that a lot of people should actually have, instead of relying on schematics all the time. So let's try this out for the last time. I did lose the power button here somewhere in my mess. It's in this room, I know it is. I'll find it, but it's missing for now. So let's turn this on. And you can tell me it doesn't want to work now. It's going to make a liar out of me. I hear a motor. Maybe that belt needs to go. So let's try a play. Can't play this stuff, it's copyrighted. Still has that awful noise.
Alright, wait, what am I saying? It's just a plane ride. Why? Because I didn't fly all the way to Juneau to be stuck in a hotel.
So yeah, it's working great.
That's why.
You won't even know I'm there.
That's quality of the picture is what it is. I do have 3 more beta machines. I'm not a beta fanatic by any chance. I prefer VHS over beta personally, but I do have 3 other beta machines. They're I think I'm not sure what brand they are, but they are super beta and they're hi-fi. So I do want to get those going because they do have some value. This machine really doesn't have much value to the collector market. I think it's more of a oddity, and these things were mass produced in the thousands and thousands, and pretty much 98% of them hit the garbage already. So, but they are interesting to work on, and they are a little bit entertaining. So that's it for this one. Thanks for watching. I hope if you want to tackle one of these machines, I hope maybe the video was helpful. And thanks for watching. Take care.